Confirming distances to quasars. All of these unusual characteristics of quasars, lots of energy, small size, very bright, to some degree is all dependent upon them being the most distant objects we see. If they weren't so far away, these characteristics would not be as extreme. You wouldn't need as much energy to explain the brightness of these things. They wouldn't be so bright. They'd still be small, but they would have characteristics as far as brightness and energy that were more consistent with galaxies or even stars. But there's this annoying thing that they're so far away, which was measured using Hubble's law and the redshift. So there were a number of people who were skeptical about how far away quasars actually were and called all of this into question. Well, we now know for certain that quasars are in fact very far away. We see quasars with other galaxies. They're in clusters of galaxies. And when we measure the redshift, they all have the same redshift within the same cluster. Now we couldn't see that when quasars were first discovered because our telescopes weren't as good. Now with Hubble Space Telescope especially, we can now see these other galaxies in addition to the quasar. And we can actually measure the redshifts of all of these. And we're getting within this entire cluster, so this little grouping of galaxies, they all have the same redshift. So that's a good clue that the redshift of our quasar is actually related to its distance. And even more importantly, quasars were found to actually be a part of a galaxy. So in this picture, of course, the very, very bright part, that's the quasar. But this other stuff surrounding it, that's an actual galaxy. So quasars are part of a galaxy. And since we are looking so far away, which means so far back in time, they must tell us something about very young galaxies, when the universe was very young. Because we don't see quasars in nearby galaxies. We only see them in these very, very distant galaxies. So we're only seeing things that are from the early universe. Now at this point, we haven't answered what is a quasar. We will eventually. But now we know for certain that they are at these huge distances, which means we are looking very, very far back in time. We now know that we're dealing with a galaxy, not just the quasar itself, but that the quasar is something found in a galaxy. And so the next question is, do we see anything like this closer to us?